So friends, we can solve this numerical in another method. In this method, we'll assume x is equal to tan theta. Always remember, if in the integration square root of 1 plus x square is there, in that case we can assume x is equal to tan theta. Like in the previous questions, square root of 1 minus of x square were there and we assume x is equal to sin theta. Okay, so similarly here we can assume x is equal to tan theta, and if we simplify after differentiation, it will be very easy. Just look. So let x is equal to tan of theta. Okay, now differentiating both sides with respect to x. So d dx of x is obviously 1 and d dx of tan theta is equal to sec square theta into d theta by dx. So 1 is equal to sec square theta into d theta by dx. Okay, so what is dx? Dx is sec square theta into d theta. Okay, now what is the integration become? The integration I is equal to, instead of dx we can use sec square theta into d theta. So writing sec square theta into d theta instead of dx, divided by square root of 1 plus of tan square theta into 1 plus of tan square theta. Okay. So definitely if we simplify, as we know 1 plus of tan square theta is equal to sec square theta. So this is sec square theta into square root of sec square theta, that is the denominator becomes sec cube theta, and sec square theta already at the numerator. So after simplifying whole we will get just 1 by sec theta, that is cos theta. So the integration will be written as I equal to integration of cos of theta into d theta. Okay. And what is integrations of cos theta? It is sin theta. So I is nothing but sin of theta plus of c, where c is the integration constant. Now to write this answer in terms of x, we have to put the value of sin theta in terms of x. So as we have tan theta is equal to x, so tan theta is equal to x. So if it is theta, tan theta is perpendicular by base, so this is x by 1. So hypotenuse becomes square root of x square plus of 1. Sure? Okay. So what is I? I can be written as, in this case the sin theta become what? Perpendicular by hypotenuse, x divided by square root of x square plus of 1. So the integrations can be written as x divided by square root of x square plus of 1 plus of c. Okay, clear? Now come to the next question. So friends, come for another example, that is integrations of dx divided by x cube into square root of x square minus of 1. So here, as square root of x square minus 1 present, that is why we will first assume x is equal to sec of theta. Okay, so let x is equal to sec of theta. So if we differentiate both sides with respect to x, we will get dx is equal to sec of theta into tan of theta into d theta. Okay, clear? So what is I? I can be written as integration of, instead of dx we are writing sec theta into tan theta into d theta. So sec of theta into tan of theta into d of theta whole divided by x cube means sec cube theta. So this is sec cube theta into square root of x square minus 1, that is square root of sec square theta minus of 1. Okay. Now let's simplify it. So I is equal to integration of sec theta tan theta d theta at the numerator, and at the denominator it is sec cube theta, writing same. So sec of theta into tan of theta into d theta divided by sec cube theta, and square root of sec square theta minus 1 is tan of theta. So this is tan of theta. So now we can easily cancel sec theta into tan theta from both numerator and denominator. So after simplifying, we can write I is equal to integrations of cos square theta d theta. Is it? Now how integrations of cos square theta d theta can be found out? We know we normally multiplied and divide by 2 first. So I is equal to half into 2 into cos square theta d theta. Now we must write 2 cos square theta as 1 plus of cos of 2 theta. So writing I is equal to half integrations of 1 plus of cos of 2 theta d theta. Okay. Now we can easily find out the integrations. So applying the formula, the integration become half of integrations of 1 into d theta means theta, plus of integrations of cos 2 theta d theta means sin 2 theta by 2. So this is half of sin of 2 theta, okay, plus of c. The c is integration constant. So I become half of theta plus half of sin theta into cos theta plus of c. Here just we break sin 2 theta as 2 sin theta cos theta. So half and 2 will be cancelled from here. So half into sin theta cos theta become half sin theta cos theta plus of c. Okay, clear? Now to get the final answer, we have to convert all of this in the form of x. So we can write I is equal to half of, as we assume sec theta is equal to x, so theta is nothing but what? Sec inverse of x. So instead of this theta we can write sec inverse of x. So this is half of sec inverse of x plus of half of, look, as sec theta is equal to x, so obviously the value of cos theta is equal to 1 by x, is it? The value of cos theta is 1 by x. So from here we can easily find the sin theta. What is the value of sin theta? Sin theta is equal to square root of 1 minus 1 by x square. Okay, so substituting the values of sin theta as square root of 1 minus x square here and cos theta is 1 by x here, we will get the final answer. So this is half into square root of 1 minus 1 by x square into 1 by x plus of c. Okay, now simplifying more, we will get I is equal to half sec inverse x plus 1 by 2 into square root of x square minus 1 by x square plus of c. Okay, clear? Now come to the next question. So friends, come to another question, that is integrations of x cube dx divided by square root of 1 minus of x square. So in this case also, as square root of 1 minus x square present, so we will substitute x by sine of theta. So let x is equal to sine of theta. So obviously we will differentiate both sides with respect to x. So differentiating with both sides with respect to x, we will get dx is equal to cos of theta into d of theta. Okay. Now what will be the integration? So the integration become I is equal to integration of, instead of x cube we will write sine cube theta. So this is sine cube theta. Instead of dx we will write cos theta into d theta. So this is into cos theta d theta whole divided by square root of 1 minus x square is there. So 1 minus x square will be 1 minus sine square theta. So 1 minus sine square theta. Okay, clear? Obviously we will simplify in the next step. Square root of 1 minus sine square theta become cos square theta. Square root of 1 minus sine square theta become cos of theta. So I is equal to integration of sine cube theta into cos of theta d theta whole divided by cos of theta. Okay. Now obviously we will cancel this cos theta, cos theta. So what is integration? The integration become I is equal to integration of sine cube theta d theta. Okay. Now how integrations of sine cube theta d theta can be solved? Obviously, we will multiply it and divide by 4. That is 1 by 4 into 4 sin cube theta, and 4 sin cube theta will be converted in the form of sin of 3 theta. So, in the next step, I can be written as 1 upon 4 integrations of 4 sin cube theta d theta. Is it? As sin of 3 theta has formula 3 sin theta minus 4 sin cube theta. So definitely 4 sin cube theta can be written as 3 sin theta minus of sin of 3 theta. Okay. So we will substitute this 4 sin cube theta by 3 sin theta minus of sin of 3 theta. So what is I? I become 1 upon 4 into integration of 3 sin of theta minus sin of 3 theta d theta. Okay. Now the integrations can be easily done. So what will be I? Applying the formula, it is 1 upon 4. Integrations of 3 sin theta will be minus of 3 cos theta. So this is minus of 3 cos theta. And integration of sin 3 theta d theta will be minus of cos 3 theta divided by 3. So this will be plus of cos of 3 theta divided by 3 plus of c, where c is the integration constant. Okay. So let's simplify it. I is equal to minus 3y4 cos of theta plus 1 upon 12 cos of 3 theta plus of c. So this is the integrations. Now to get the final answer, we have to convert this whole results in the form of x, where sin theta is equal to x. So when sin theta is equal to x, then cos theta is equal to square root of 1 minus x square. So further simplifying this, we can write I is equal to minus 3 by 4 cos theta plus of 1 by 12. Cos 3 theta can be written as 4 cos cube theta minus 3 cos theta. So this is 4 cos cube theta minus 3 cos theta plus of c. In the next line, we will write minus 3 by 4 cos theta, and here we will again get minus 1 by 4 cos theta. Look, minus 3 by 4 cos theta plus 1 upon 3 cos cube theta minus 1 upon 4 cos theta plus of c. Okay. So what is I? I will be minus 3 by 4 cos theta and minus 1 by 4 cos theta, that is minus cos theta. So we can write this is minus cos theta plus 1 by 3 cos cube theta plus of c. Okay. Now substituting cos theta by square root of 1 minus x square, as sin theta is equal to x. So what is I? We can write finally I is equal to minus square root of 1 minus x square plus of 1 upon 3 1 minus x square whole to the power 3 by 2 plus of c. Okay, clear? So this is the answer in detail. Now come to the next question. So friends, come to another question, that is integrations of x squared plus 1 divided by x square minus 1 whole square dx. Okay. Now to solve this type of numerical, we will first assume x is equal to tan theta. So look on, let x is equal to tan of theta. So differentiating both sides with respect to x, what we will get? Dx is equal to sec square theta d theta. Okay, clear? Now come to the integration. I is equal to integration of x is tan of theta. So this is tan square theta plus of 1. Instead of dx, we can write sec square theta d theta. So sec square theta d theta whole divided by tan square theta minus of 1 whole square. Okay, clear? Now let's simplify this. I is equal to integration of tan square theta plus of 1 is sec square theta. So we are writing sec square theta into sec square theta, that is sec to the power 4 theta. So sec to the power 4 theta d theta, and writing this tan square theta as sin square theta by cos square theta. So if we simplified it, it will be sin square theta minus cos square theta by cos square theta whole square. So sin square theta minus cos square theta divided by cos square theta whole square. Okay. Now let's simplify more. So what will be I? I is equal to integrations of cos square theta whole square is cos to the power 4 theta, and it will come at the numerator. Cos to the power 4 theta into sec to the power 4 theta will be 1. So the numerator become d theta. So at the numerator we just write d theta. And at the denominator it is sin square theta minus cos square theta whole square. Sin square theta minus cos square theta whole square can be written as cos square 2 theta. So this is cos square 2 theta. Okay. So what is I? I can be written as integrations of sec square 2 theta into d theta. So it is sec square 2 theta into d theta. Now it is easily integrable. We know integrations of sec square 2 theta is tan of 2 theta divided by 2. So this is tan of 2 theta divided by 2 plus of c, where c is the integration constant. Now this is the integration. Now to get the final result, we have to transform this tan of 2 theta in the function of x. So for this we have already tan theta is equal to x. So first of all we will break tan 2 theta as 2 tan theta divided by 1 minus tan square theta, and we will substitute tan theta by x. Okay. So what will be I? I is equal to tan theta divided by 1 minus of tan square theta plus of c. So what is I? Substitute just tan theta by x. So I is equal to x divided by 1 minus x square plus of c. So this is the final answer. Okay, clear? Now come to the next question. So friends, let's come to another question, that is integrations of square root of x divided by a minus x dx. Okay. Now to solve this type of numerical, we will first assume x is equal to a sin square theta or x is equal to a cos square theta. Okay. So we are assuming here, let x is equal to a sin square theta. So let x is equal to a sin square theta. So differentiating both sides with respect to x, we will get dx is equal to a sin of 2 theta d theta. Okay. Now what will be the integration? So the integration become I is equal to integration of square root of a sin square theta. Instead of x, just we will put a sin square theta divided by a minus of a sin square theta, and instead of dx we will put a sin 2 theta d theta. Okay. So this is a sin of 2 theta d of theta. Clear? So simplifying more, I is equal to integration of, here a and a will be cancelled from both numerator and denominator. The numerator will be sin square theta and the denominator will be 1 minus sin square theta, which will be cos square theta, and sin square theta by cos square theta will be tan square theta. Square root of tan square theta become tan of theta. So we are writing here tan of theta, and a can come outside. So a into integrations of tan theta, and sin 2 theta can be written as 2 sin theta cos theta. So we are writing 2 sin theta into cos theta d theta. Okay. So what is I? I will be a into integrations of tan theta into sin theta into cos theta will be what? 2 sin square theta, because tan theta can be written as sin theta by cos theta and cos theta can be cancelled. So sin theta into 2 sin theta become 2 sin square theta. So this is 2 sin square theta d theta. Okay. Now 2 sin square theta can be written as 1 minus cos of 2 theta. So we are writing I is equal to a into integrations of 1 minus of cos of 2 theta d theta. Okay. Now it is very simple to integrate. So I become a into integration of d theta is theta. So we are writing theta minus integration of cos of 2 theta d theta is sin 2 theta by 2. So we are writing here sin of 2 theta by 2 plus of c, where c is the integration constant. Okay. So this is the integration. Now to give the answer in terms of x, we will use sin theta as square root of x by a. So for this, first of all, we will write in this way: I is equal to a into theta minus break sin 2 theta as 2 sin theta cos theta. So sin 2 theta by 2 can be written as what? It is sin theta cos theta. So sin of theta into cos of theta plus of c. Okay. So here we have the tool x is equal to a sin square theta. So as x is equal to a sin square theta, so from here we can write sin of theta is equal to square root of x by a. Is it? So we can use this. So I can be written as a into theta will be sin inverse of square root of x by a. So we are writing sin inverse of square root of x by a minus sin theta is nothing but square root of x by a. So just we are writing square root of x by a instead of sin theta, and cos theta will be square root of 1 minus sin square theta, and sin square theta we know it is x by a. So we are writing here x by a plus of c. Okay. So this is, we can simplify, I is equal to a into sin inverse of square root of x by a minus of square root of ax minus of x square plus of c. Okay, clear? Now come to the next type of example. So friends, come to another example, that is integrations of tan of 2x into tan of 3x into tan of 5x dx. Okay. Now to solve this numerical, we will use a trick. Just look, what is the trick? First of all, tan of 5x can be written as tan of 3x plus of 2x. Okay. This tan of 3x plus of 2x, if we apply tan of a plus b formula, so this can be written as tan of 3x plus tan of 2x divided by 1 minus tan of 3x into tan of 2x. Okay. So tan of 5x is tan of 3x plus tan of 2x divided by 1 minus of tan of 3x into tan of 2x. Now if we make cross multiplication, what we will get? Tan of 5x minus tan of 5x into tan of 3x into tan of 2x is equal to tan of 3x plus tan of 2x. So tan of 3x plus tan of 2x. Okay. So what is tan of 5x into tan of 3x into tan of 2x? As we have integrations of tan of 2x into tan of 3x into tan of 5x dx. So first of all, we will separate this tan of 5x into tan of 3x into tan of 2x. So we can write tan of 5x minus tan of 3x minus tan of 2x is equal to tan of 5x into tan of 3x into tan of 2x. Okay. Now we will use this result, that is tan of 5x into tan of 3x into tan of 2x as tan 5x minus tan 3x minus tan of 2x. So what will be the integration? The integration can be written as now I is equal to integration of, instead of whole of this, we will write tan 5x minus tan 3x minus tan of 2x. So this is tan of 5x minus tan of 3x minus tan of 2x dx. Okay, clear? Now we can split into 3 integration. So in the next line, I is equal to integration of tan of 5x dx minus integration of tan of 3x dx minus integrations of tan of 2x dx. So it is tan of 3x dx minus integration of tan of 2x dx. Okay, clear? Now these are easily integrables because integrations of tan of mx we have formula 1 by m log of mod of sec of mx, is it? So we can write I is equal to 1 by 5 log of mod of sec of 5 of x minus similarly integrations of tan of 3x is 1 by 3 log of mod of sec of 3x. So this is 1 by 3 log of mod of sec of 3x minus integration of tan x dx will be 1 by 2 log of mod of sec of 2x. Okay, so 1 by 2 log of mod of sec of 2x plus of c, where c is the integration constant. Okay, clear? So in this way we can solve this type of numerical. Now come to the next type of example. So friends, come to another question, that is the integrations of sin x divided by sin of x plus a dx. Okay, now to solve this numerical we will first substitute x plus a by a new variable, that is v. So let x plus of a is equal to v. Now differentiating both sides with respect to x, we will get dx is equal to dv, and also we get x is equal to v minus of a. Now what will be the integration? So the integrations will be, instead of sin of x we can write sin of v minus of a, as x is v minus of a, and at the denominator it is sin of just v, as we assume x plus of a is equal to v, and instead of dx we will write dv. Okay, clear? Now at the numerator sin of v minus a is there, we can apply sin of a minus b formula. So this is sin v cos of a minus sin of a into cos of v, okay, whole divided by sin of v dv. Clear? So what is I? I will be integration of this sin v cos a divided by sin v. So sin v can be cancelled. So this will be simply cos a. So we are writing cos a minus sin a into cos b divided by sin b. So that can be written as sin a into cos b by sin b is cot of v. So this is sin of a into cot of v dv. Clear? Now we can split into two integration. So what will be the integration? I is equal to integration of cos of a dv. So this is cos of a into integrations of dv, as a is constant, so sin a cos a both are constant, minus sin of a into integrations of cot of v. Okay, clear? Now we can easily apply the formula of the integrations. So what will be the integration? I is equal to cos of a, and instead of integrations of dv we will write v. So v minus sin of a, and integrations of cot of v dv is log of mod of sin v. So we will write into log of mod of sin of v plus of c, where c is the integration constant. Now to get the final results in terms of x, we will substitute v by x plus of a. So I is equal to cos of a into x plus of a minus sin of a into log of mod of sin of x plus of a plus of c. Okay. Now look at the last line, we can write what? I is equal to x into cos of a, and this a into cos of a is a constant, and this constant when include with this integration constant, it will give a new constant. Okay, we can assume that constant as mu or nu, like this. So the integration become x into cos a minus sine of a into log of mod of sine of x plus of a plus of lambda, where lambda is the constant which is basically equal to c plus of a into cos of a. So this is the answer for this integration. Clear? Okay. Now come to the next type of question. So friends, come to another question, that is integrations of square root of sin x into cos cube x dx. Now to do this numerical, we'll first write this cos cube x as cos square x into cos of x. So this integration can be written as square root of sin of x into cos square x into cos of x dx. Okay. In the next step, we can write this is square root of sin of x into this cos square x can be written as 1 minus of sin square x. So this is 1 minus of sin squared x into cos of x dx. Now why I write in this way? Because if we substitute sin x by any variable v, the derivative of sin x is cos x dx. Okay, in that case, the whole integrations will be in terms of v and dv. So just assume, let sin of x is equal to v. Now differentiating both sides with respect to x, what we will get? Cos of x dx is equal to dv. So the integration can be written as I is equal to integration of, instead of sin x just we will write v, that is square root of v into 1 minus of v square, and this cos x dx can be written as what? Dv. So this is dv. Okay. Now the integrations can be simplified in the form of I is equal to integration of root over v, that is v to the power half, minus root v into v square, that is v to the power 5 by 2 to dv. Clear? So the integration can be written as I is equal to integrations of v to the power half dv minus integrations of v to the power 5 by 2 dv. So what is I? So I is integrations of v to the power half can be written as, it is v to the power 3 by 2 by 3 by 2 minus, and integrations of v to the power 5 by 2 dv can be written as v to the power 7 by 2 by 7 by 2 plus of c, where c is the integration constant. Okay. So what is I? I is equal to 2 by 3 v to the power 3 by 2 minus 2 by 7 v to the power 7 by 2 plus of c. So this is the integration. Now to get the final answer, we have to substitute v by sin of x. So what is the final answer? I is equal to 2 by 3 sin x whole to the power 3 by 2 minus 2 by 7 into sin x whole to the power 7 by 2 plus of c. Okay, clear? Now come to the next type of example.